So good morning, everyone. I'm Claudia Hodgson, and this is my colleague, Daniel Graveling, and we're going to walk through today all about the real-time capabilities in the ArcGIS system, and there will be a bit of a focus on some of the kind of newer products and the newer capabilities. So as the world is growing increasingly digital, we're seeing an uptake in the use of Internet of Things. So this could be anything from sensors on vehicles, river gauges, farming equipment, or even the smartwatches that many of us wear every single day. And its use is expanding as well across almost every industry. So maybe you want to track personnel or track your assets, have a better understanding of resource optimization, or even to have a live picture of your operations. And this increasing number of sensors as well brings with it a rapidly growing library of real-time data. So it's providing us with these great opportunities to visualize data with a live picture of patterns, trends, and events. And we're continuing to grow these capabilities as well. So it's to the extent that you can actually rely on the ArcGIS system from the point of collecting your data, ingesting it into the system, visualizing it, all the way through to analyzing real-time data. And here we have a collection of apps that let you do just that. So firstly, we've got two of our field applications there, ArcGIS Field Maps and ArcGIS Quick Capture, capable of collecting real-time data. We've then got ArcGIS Velocity, so that's our cloud-based solution for ingesting external sources of observational data, such as other IoT platforms, third-party APIs, and data providers. Now, I should say here that it's not actually the first to bring this real-time ingestion. ArcGIS Geo Event Server has enabled us to ingest stream data into your enterprise GIS, but then Velocity brings all of this to the cloud. So it's at your fingertips in a browser, all as an extension to your ArcGIS Online subscription. Then, because it's all in ArcGIS Online already, you've got all of the tools and the capabilities to visualize your real-time data, whether that's in Map Viewer and using a number of different app builders, or you could even take it into desktop using ArcGIS Pro, all of which support this real-time data visualization. And then lastly, we've got Analyze, because ArcGIS Velocity isn't just about ingesting real-time data, it's also a system for analyzing that real-time data as it's coming in, all in real time. So in this session today, we're going to showcase a number of these apps shown here to really explore the extent of these real-time capabilities. And we're going to do that by following this workflow you can see. So firstly, how do we collect real-time data using ArcGIS? How do we ingest it into the ArcGIS system? How do we visualize it? And then lastly, how can we analyze this real-time data as well? And we're going to actually do this by expanding on an example that you have already seen today. So earlier this morning in the opening plenary, Claire showed the art of what's possible with real-time, visualizing a number of different live feeds across the city of Edinburgh through a digital twin. So this session is going to delve a little bit deeper into this bus bunching scenario, as well as taking it one step further with some additional real-time analysis. So to kick off, the first step is collecting real-time data. So I'll now hand over to Daniel, who's going to show exactly that, how to collect real-time.
Thanks, Claudia. So real-time data can be collected within the ArcGIS system through location sharing. Location sharing is an organisation-wide capability that allows you to record where mobile workers are and where they've been. First introduced with ArcGIS Tracker, location sharing is now supported in two of our field applications, ArcGIS Field Maps and ArcGIS Quick Capture. When you enable location sharing and a mobile worker authorises their location to be shared, licensed users in your organisation can use our mobile apps to collect and upload their location tracks to location track layer. Data tracks can only be viewed by licensed users in the Track Viewer web app and on field apps by mobile workers with an appropriate license. I should also add that in order to use tracking, you require an organisational account on ArcGIS Online or ArcGIS Enterprise 10.7 or later. You may also be wondering what effect location sharing has on the battery of my mobile device, and what if a mobile user doesn't want to have the location tracked? Well, both the Field Maps and Quick Capture mobile apps are optimised for location sharing in the background, minimising the impact on device battery, and both apps even record tracks in offline environments. The benefits of this include being able to work remotely without access to stable internet connection or working in sites where mobile data signals are prohibited. And just to stress again, all of our apps always provide the individual user with control of whether to share their location. So when a mobile worker accesses a map or form in ArcGIS field maps or quick capture where location sharing is enabled, they'll receive a notification informing them that they are required to turn on location sharing. Once in the map, they have the option to view their own tracks and choose whether or not to upload them. And in one of ArcGIS field maps' latest releases, its location sharing capabilities have expanded even further with the ability to configure location-based actions for your mobile workers, thanks to its new geofencing capabilities. For those of you who aren't aware what a geofence is a defined area on a map that when entered or exited can send alerts or enable location sharing in the ArcGIS Field Maps mobile app. So a geofence in field maps can be used in one of two different ways. The first is to send location alerts. So for example, you may want to let mobile workers know when they're entering hazardous or restricted areas. The second is to control location sharing. So you may wish to know the location and tracks of your mobile worker when they're on company property or enter a specific work zone. So now that we've learned a little bit about location sharing and geofencing, let's take a look at how to set it up in field maps. So here we are in the ArcGIS Field Maps web app. And now, as I mentioned earlier, we're going to be sticking with our bus theme for the opening plenary and take a look at how we can track drivers and send alerts within our app. So in this map, we have just a small section of our bus network, specifically the route of the X37 Lothian bus, which you can see here in purple. All of the orange points along our route are bus stops. So to show off geofencing capabilities in the field maps, we're going to set up geofences to both alert the driver when they're approaching a stop and to control their location sharing when they're on their route. So on the left-hand side here, you'll see the geofencing tab where we can configure our geofences. Now, currently, you can only define geofences using existing polygon layers, but for today's session, we're using the early access version of field maps, where we can set buffers around point and line features to act as a geofence. This feature will be coming to field maps general release from early November. So first, I'll add a geofence. So first I'm going to add a geofence to let the bus drivers when they near stop along their route. So when I click Add Geofence, the new geofence pane appears, and this is where we can configure the properties and actions of the geofence. I'm going to name this geofence X37 Bus Stops. And I'm going to use the bus stops layer from our actions. So as this is a point layer, I'm then prompted to set a buffer distance around the point. If I zoom in and change this to 200 feet, you can see the buffer updates automatically. So now I want to configure an action when the bus driver enters this 200 feet buffer zone. So in the type drop-down menu, I'm going to select Location Alert, and I'm going to select the On Enter box. So in this example, I only want to notify bus drivers when they're nearing the proximity of a bus stop on their route, but I could also send a notification when they're exiting the area by checking On Exit. So we can further configure this alert by adding a message to the notification text that appears in the mobile app. So for the On Enter text, I'm going to type, "You're approaching a bus stop." So additionally, we can use the Add Field button to bring in field values from our chosen layer. So in the message here, I could specify what bus stop the driver is approaching, which is the common name field. There we go. So now that's configured and saved, you can see our geofence has been added to our map. So next I want to set up a geofence that enables location sharing of my bus driver only when they enter their route. So when the bus driver leaves the route, location sharing will automatically be disabled. This is because we only want to track the bus driver on shift and not when they're commuting to and from their shift or outside of work hours. So to do this, it's a similar process. I'll add a geofence, and this time I'll name it X37 route. And for my layers, I'll select the X37 route. Again, I can change the buffer distance, so I'll change this to 200 feet. But this time, from actions, I'm going to select location sharing. Start and exit, start and enter, stop and exit. And just like that, we've set up both location sharing and location-based geofences on our drivers. And just to show you how these notifications we set up appear to the mobile worker, here we have 2 screenshots of the application in action around Edinburgh. So on the left, we have our notification informing the driver they're nearing a bus stop with the name of the bus stop displayed. And on the right, we have our location tracking notification informing the mobile worker that the location is now being tracked. So let's also take a quick look at how this track data appears in the Track Viewer web app. So here we can see the track viewer showing the track of a bus driver as they enter their route. The location is recorded upon entering the predetermined geofence area and stops when they exit this area. So we've collected this screenshot ahead of time while the user was out in the field. So you can see where our bus driver's live location is when the screenshot was taken. Within the track viewer, administrators can set up what's called a view and specify the workers they wish to monitor. As soon as you set up a view, as we can see here, you can see where your mobile workers have been and where they are now. So not only this, but tracks also collect additional information, such as device battery, location accuracy, heading and speed. This kind of data can be used to feed real-time analysis, which we'll see in just a second. It's important to remember that only users with admin privileges and appropriate licenses assigned can view track data, so it's hidden from other users in your organisation. So now that we know how to collect real-time data, I'll hand you back to Claudia, who's going to take us through ingesting some real-time data with ArcGIS Velocity.
Thank you. So, how exactly can we ingest real-time data? Well, as I mentioned, ArcGIS Velocity is simply an extension of your ArcGIS online subscription. So here I am in the Velocity homepage in my ArcGIS Online account. And the first step for ingesting real-time data is to create a feed. Now, there are many different types of feeds that you can create, so whether it's from an existing ArcGIS layer, from a cloud service, from a web or messaging service, or from a data provider. In this case, I'm going to use the open bus data that was used in the bus bunching scenario from the opening plenary. So that's from a poll to a HTTP. And we're then guided through this wizard-like experience for configuring our feed. So firstly, I need to add my URL to collect my data. And then as soon as I click Next, Velocity is getting to work, it's collecting all of my data, and it's deriving the schema for me. So I don't need any advanced knowledge of data structures or anything, it's doing all of this for me. I'm then just going to add the root node vehicles to further flatten my data and retrieve those further attributes within that. And here is where we can also, I could change the field names if I want to, I could change the field types if necessary, or I could even remove some of these fields if I'm not needing to include them. In this case, I'm happy with how it is, so I can move on to the next step. So this is where we identify our key fields, or in particular, our spatial and our temporal fields. So for location, I've got X, Y fields. And you can see again, Velocity's read all of our data and has populated these for me already. For date and time, we haven't actually got a specified date field, so I can select no. And then lastly, our track ID. In this case, I'm going to set it as my vehicle ID. And I can move along to the next step. Now this step is where we specify how often we want ArcGIS Velocity to query our data source. So the default here is every minute, every day. What I really want as live a picture as I can get of this bus network. So I'm going to go ahead and set it every 10 seconds. And lastly, of course, the final step is we need to name our feed. So I'm going to go ahead, type in live buses for Edinburgh. And then as soon as I click complete, ArcGIS Velocity is going to initialize and then run this feed straight away in the cloud. And because it's all in the cloud, I can straight away visualize all of this. I can simply add a stream layer to Map Viewer to visualize the live locations of these buses. So let's jump straight back into the browser. And here you can see these buses. So this is updating around every 10 seconds, so we have a live picture of the buses across the city of Edinburgh. And because we're in Map Viewer, you've got all of the tools and the capabilities to visualize this how you want by customizing the symbology and the properties of this layer. For example, I could go ahead and I could add labels to this. I could simply add the service name of these different buses to instantly have a better understanding of which buses are located across Edinburgh. Now, I know this is quite a simple symbology shown here, but we really did see the extent of what's possible in the opening plenary, with Claire using both a 3D mesh and then 3D symbology for the buses as well. But what makes ArcGIS Velocity incredibly powerful is the ability to perform real-time analytics on the fly. So this is where we move on to our fourth and final step, analyse. And we're going to go back to the bus bunching analytic that Claire showed in the opening plenary. Now, I know that this may look rather daunting, it's quite a large analytic, but I will go through each step. But firstly, just to say about ArcGIS Velocity's analytical view, it's very, very similar to ArcGIS Pro's model builder. So if any of you have used that, you'll feel some similarity with this interface here. ArcGIS Velocity has a number of different analytical tools for you to use, and they're categorized by their capabilities across the top here. So we've got data enrichment, find locations, manage and summarize data, and use proximity. And then it's simply a case of finding the tool that you want, dragging it into the analytic, and then simply linking them up to one another. So let's have a look and let's go through this analytic. Firstly, we've added the feed that we've created, so our live locations of buses. We're then using the project tool to reproject it to British National Grid. And then we begin to determine whether buses are bunched or not. Now, if you're not a regular bus rider, bus bunching is just the frustrating occurrence of when you're waiting for a bus, then round the corner comes two, the same number going the same way around the route. So you're always likely to have an empty bus following behind. So not only for passengers, this is quite annoying, but also from an operational point of view, it's not very efficient as well. So how do we define whether buses are bunched or not? Well, firstly, we use the Calculate Field tool. So this is in the Manage Data folder. And we're using this to write a simple arcade, which you can see on the just around here, where it's adding both the journey ID of each bus and their heading along the route. And this creates a new field called service number. We're then wanting to determine the bus's proximity to one another. So we're using the Calculate Distance tool. And we've set here a search radius of 200 meters, but we've also added an attribute relationship. So that they might be 200 meters in proximity, but are they both the same service number? So the same bus number and the same heading round the route. We've also added a join time window. So this is simply how long the historical data is stored for calculating this particular tool. And then using the Calculate Distance tool, it's providing us with an additional field called Distance to Feature. So this is the field that we use to define whether buses are bunched or not. And we do that by using another Calculate Field tool. So here you can see we've got another arcade expression. This time it's simply defining buses. If the Distance to Feature field is empty, then buses are defined as not bunched. But if their Distance to Feature field is populated, then buses are defined as bunched. And that's it really. That tool has then defined whether we have bunched buses or not. But we wanted to have a greater look and really a better understanding of the operational picture, and we had to consider that buses may be stationary and likely bunching at bus depots. So that's exactly what you can see over here. So we've added another polygon feature layer, and this is our monitoring zones, which is the entire city of Edinburgh, but excluding those polygons of bus depots. And we're then using the Filter by Geometry tool to only select the buses that are intersecting with these monitoring zones. We're then using another filter tool, this time Filter by Expression, to only provide us with the buses that are defined as bunched. And we've then got that as an output feature layer showing us the only buses that intersect with the monitoring zone and the only buses that are bunched. We've then done the same again, so we've got another filter by expression for the buses that aren't bunched, shown in an output feature layer again. And we've added another polygon layer down here, which is all of our bus depot zones, so we can see exactly what buses are at bus depots as well. And then to get an even more accurate picture of our bus network, we've added in some external data. So this is coming from Waze, providing us with the live traffic and road conditions across Edinburgh. So it may cause reasons for bus bunching, whether there's road closures or traffic jams, etc. And again, that's shown in an output feature layer. Now, I know this is quite a large analytic, but with ArcGIS Velocity, you can simply start with one feed and one output feature layer, and then begin to build your analytic. So you could add additional analytical tools, check that it's still working, and then continue to build that analytic. So even here, I could add additional features to this analytic, such as earlier in this session, Daniel showed geofencing and field maps. But ArcGIS Velocity can perform geofencing as well. And we've even actually already included some in this analytic, such as the filter by geometry. This is geofencing by determining only buses that intersect that monitoring polygon zone. So that's performing geofencing. But ArcGIS Velocity can also perform dynamic geofencing. So identifying a spatial relationship between features coming from a join feed and from a target feed, both of which are updating in real time or near real time. For example, here I've got another analytic, but it's exactly the same. I've just added an additional layer at the bottom here. So we're bringing in the location sharing layer of our bus drivers across the city of Edinburgh. And after using the project tool again, we're now using the join features tool to set up a dynamic geofence so that any bus drivers within 100 meters of an incident coming in from Waze, so that could be a road closure, traffic jam, weather hazard, anything like that, will then be fed into this output feature layer. So if needed, we can tell the bus drivers they may need to deviate from a route for whatever reason. And as well as this, there's an additional analysis capability within ArcGIS, within the ArcGIS system. The ability to be able to actually have a live picture of your operations on one single display. And so for that, I'm now going to pass back to Daniel, who's going to show exactly that.
Thanks. So now that we've seen how Velocity can incorporate and process multiple data streams, let's take a look at what this data looks like when we pull it into an operational dashboard. So at the centre of the dashboard is a map showing our live bus data, which Claudia set up earlier in Velocity. We have symbolised the point data so that buses appearing in red are bunched and those in blue are not. On the left, we have a list showing the service number and bearing of buses, which are currently bunched. And at the bottom, a simple counter widget, which if you are familiar with dashboards, you may have seen before. This displays the number of buses currently bunched and updates at the same interval as the live layer. Along the top, we have another indicator informing us of the number of bunched buses, as well as a total count of the number of buses in operation. If you remember the analytic from earlier, this only takes into account buses which aren't within the proximity of a depot. So next to that, we have data from our external source in the form of Waze information, which was demonstrated earlier in Velocity. This is being pulled into our dashboard, showing us live traffic jams and road closures as they happen. And finally, we have our map content pane, which is where we can see bus information, as well as the details of the drivers that are currently on shift. So this data is being pulled in from the track layers we set up earlier on field maps. Now, dashboards like this, one for ArcGIS Velocity, allow organisations to see large volumes of data in real time, all in one operational view, and effectively help users to understand live situations as they develop. And with that, we hope that you've seen the breadth and power of our real-time capabilities and that you're inspired to try out some of these features for yourself. If you have any questions, we'll be taking them shortly, but thank you for listening.